Okay, this question is asking us to take these cyclohexane rings and draw them as chair conformations. And at this point, we're not trying to think about higher energy or lower energy. We're just taking the projection that we see and we're drawing it as a chair conformation. So that means there's going to technically be two right answers. I'm going to not draw both of them. And so we'll talk about each one a little bit more and how you'll know whether or not you have the right answer. Okay, so this is what I do. One thing for students is you're going to have to learn how to draw this basic chair framework. This was provided for you, but you're still ultimately going to have to learn how to draw this particular framework and the opposite framework as well. The next thing you should do is work on a consistent method to draw equatorial and axial bonds. For me, I always start in the top left corner and I always draw an axial bond in the up position in that location. So something like this. Then I go around the circle and I draw an alternating set of bonds. So that was up, down, up, down, up, down. So let's do that with the rest of them. So up, down, up, down, up, down. And for the last one, I'm going to do the same thing, up, and I'm going to go up, down, up, down, up, down. Now what we want to do is to draw the equatorial bonds. And so remember that an equatorial bond will face the opposite, will point the opposite direction that the axial bond on that atom does in comparison. So for instance, in the top left corner, we started with an up axial bond. So I'm going to have an equatorial bond and it's going to point down. The next one, as I go around the circle and count clockwise, it's going to be harder to see that it's pointing up because I'm going to have it sort of projected towards the back, but it is also in the up direction. So it was down, up, down, up, down, up. So let's go ahead and do that there. Down, and I'm going to go around the other way. Down, up, down, up, down, up. Last one, down, up, down, up, down, up. And so now that I have the framework of the bonds drawn out, now I can put the groups on the bonds. Now here's the thing, it doesn't matter where you start, but once you start, then you have to be consistent with that choice. So I can literally put the bromine on any bond I want. Now, it is an advanced consideration and you have to be good at seeing in three-dimensional dimensions. It doesn't actually matter if you put it up or down, as long as you're consistent. But what I'm going to do to keep things consistent and simple for the learning is to say by convention that if it's a wedged bond, it's pointing towards me and we'll call that up. If it's a dashed bond, we'll call that pointing away from me and we'll call it down. So at the end of the day, it doesn't actually matter as long as you're consistent with the physical reality of the drawing. But for consistency, I'm going to say dash, down, wedge, up. So what else doesn't matter is what atom you start on, as long as you're consistent with the physical reality of the structure and you draw it correctly. So I've got a bromine and it's pointing and I'm going to say the down position. So I'm going to start it on a down bond. Now, remember, there's actually two pictures and maybe both pictures are equivalent, but when we draw rings, we always can draw a ring flip. Sometimes they're the same version, but oftentimes they're not. Which one you draw isn't going to matter. And so I'll just show you both versions for this first one, and then I'll just pick one for the next one. So I could just say, all right, look, I've got a bromine and it's pointing down right there. I could have done it here. I could have done it here, or I could have done any of the other down bonds. It doesn't matter. I'm going to start here arbitrarily. So now what I've done since I've started there is I have to be consistent. I know that the bromine is here. And so there's 1, 2, 3 other spots around the circle until I get to the methyl group. So 1, 2, 3. Now I could have gone around the other way. That's no problem. 1, 2, 3. And look, I end up in the same place. So this is the location where that methyl group is. And so here's the most important thing to do. Now that you've decided that, you have to be consistent with the reality of the picture. The bromine and the methyl group point the same way. We said down. Which bond points down on the atom where the methyl group is? Is it the axial bond or the equatorial bond? Well, in this case, it's the equatorial bond. That's the one that points down. So now you have the bromine and the CH3 pointing in the same direction. Okay, let's just, for this one, I said I'd show you both versions. So let's just start over. All right, let's draw the bromine on some other bond. Let's draw the bromine on this bond. Okay, so I made it in the down position. And so I want to go around the circle 3 spots. Let's go this way this time. 1, 2, 3. We know that the CH3 has to point in the down direction. So the down direction in this case is the axial bond and not the equatorial bond. So what I'm showing you is both versions of the ring flip. Although this is not how we would typically do it from a convention standpoint, but it is correct from an energetic standpoint. And so whatever version you end up drawing, just make sure that you're consistent. Make sure that you have a bromine and a CH3 pointing in the same direction, and that there are 2 atoms, 1, 2, in between them. Okay, so what about the next one? The next one has just got a CH3 group, and it's pointing up. So there, we're good. Now, one thing I didn't say is, well, what about all the other bonds? I'm going to leave them blank, but it is to be understood that all of the other bonds are hydrogens. All of the other bonds are hydrogens. And I know I just said I'm going to leave them blank. I just changed my mind. So let's go ahead and fill in all the hydrogens. All of these are hydrogens. Now, we said that the CH3 was pointing up. We could have as easily have chosen this bond to make the CH3. And that would have made this a hydrogen. Both of those would be right. We'll talk about which one is better later, which one is lower energy later. Okay, so let's take a look at this next one. I've got a methyl group and a 1-methyl ethyl group, an isopropyl group, and they're facing the same direction. We're going to call that direction up. And so this time I'm going to start with the isopropyl group. So the isopropyl group can go here. And that means that there's 1 atom in between the isopropyl group and the methyl group, and the methyl group points in the same direction. And so everything else is a hydrogen. Okay. So that's it for this question. Of course, remember I could have put the methyl group and the isopropyl group on axial bonds, or excuse me, equatorial bonds as well, as long as they're pointing in the same direction.